Okay, this is going to be example 3 of VR. This is actually an example that was asked on the Discord server quite a while ago by Badzabu. So if this looks familiar, that's why. This is a 5-quarter turn example, so a 5-quarter turn skeleton on RL axis without R2 or L2 moves. So this actually is going to showcase some things that are going to happen. So let's, well, I haven't even done the scramble, so let me perform the scramble. Okay, so yeah. Now let me perform the leave slice. So R, B2, R, F2, R prime, B2, L, D2, L, D2. So we got a VR skip. So here's the thing. Because there's no R2 or L2, then if the centers are solved, we'll need to do 2 M2 insertions in sub 2. And so that would be at least a +2. If the centers are, unless you get a skip. In this case, that's +0. If the centers are unsolved, then this is going to be either 1 or 3 M2 moves, M2 insertions. So that's going to be at least a +1. So basically, what we're going to do is we're going to look for all VRs and then quickly look at all the ones with solved centers just to make sure that there is some, whether there is something that skips or not. And then we're just going to look at the ones that unsolved the centers. And see if there's a +1 from there. Because usually there's going to be a +1 somewhere, at least. So the first thing you got to do actually is convert this into numbers. So notice you haven't actually done anything yet. I'm just rambling. So the goal number is 0. And my convention for RL DRs is that if the last non-RL move is U2 or D2, then this is a plus, so this is plus. Then no change axis, no change axis, change axis, no change axis. And let's put pipes in here. All right. So this is our converter. This plus actually is completely irrelevant. All right, and the goal number is 0. So let's actually see how we can get VR. So we can do nothing, and we get this one. But this will at least a +2. So pretty much not considering this. We can pick these two. We can pick these two. We can pick all. We can also pick the first one and the third segment, or we can pick the second and this segment. And we have 5 plus 1 because the do nothing one. So we have 6 VRs, and we know that for if you have 4 segments, 4 non-null segments, then there's going to be either 5 or 6 VRs in +0. That's because 2 to the 4 is 16. If you divide by 3, that's between 5 and 6. So it's either 5 or 6. In this case, we actually have all 6. You can check that the sum is equal to minus this as well. It's not hard to do. All right, so what do we do now? Now we need to check if the VRs solve the center or not before even checking them. So, okay, in this case, for example, here, we insert in an M and another M, so actually this unsolved centers. So I'm just going to use complexes notation to write down what center case we have at the end. In this case, well, this is something with minus. Notice that this minus is different from this minus. This minus is referred to like some integers modulo 3. In particular, they refer to mod phi group and stuff. So this is for step 1 only. This is for step 2. So this is in particular an integer modulo 2. It's either +1 or -1. Well, +1 or -1 isn't exactly integer mod 2, but it's isomorphic. You know what I mean? So this is minus. Here we have R and R prime, so M prime and M. So this is plus. R and L. This is plus. This is M prime and M. Here we inserted, well, here we have like inserted 2 M primes and 2 M's, so this is plus. And here we insert M prime M, 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 so this is minus. So we want to check these 3 first, and like this one, but like whatever. So we want to check these 3 to see if any of them skip. I'm also going to showcase a trick involving Sevatianos-Toronto's slice theory. In particular, notice how here we only picking one big contiguous segment of moves, right? And so if you look at the sequence in the middle, this is B2, F2, U2, D2. This is an I sequence, and it is the insertions is going to be bounded by an M prime and an M. So actually, this means that this skeleton is the same, like gives the same result as doing nothing. Now, ordinarily, you should check this because maybe there's an R2 in the middle that is different. But here, because we're just checking if it skips or not, we just know this is going to be G, without even having to do anything on the cube. So now let's just, I'm rambling so much, but I swear this is fast. No, let's actually let's do the second VR, so let me backtrack. And let's widen. And okay, we are lucky, we got U. And we can't really do the same trick because B2F2 is a D sequence. Okay. And let's just do the third one, so. And we get F, so we get unlucky again. So. Alright. So let's just do the first one. So that's RB2, RF2, RYD2, LD2, LYD2. Wait, that's I made a mistake. Hold up. Let me just let me do the scrum again. All right. So as I was saying, let's do the first VR, the RB2, RF2, RY prime, D2, LD2, LYD2. So that's M2. So that's G minus. And let's just immediately check whether this has a VR in +1. So we just need to look at all the QTs to see if any of them have a G for opposite edges. So here we obviously don't. It's not good. Ly prime, D2, no. L prime, U2, no. R wide, F2, no. R prime, D2, and no, we're unlucky. So actually, this is at least a plus. Actually, I don't know. I don't know if it's even do. That's a +2 actually. That's +2 because you can use it at the end. Let's check this one, this last one. So this is RB2, R wide F2, R wide prime U2, LYD2, LYD2. And okay, so this is a little caveat. This is not U. These are not switching. Although it looks like this if you're looking relative to the centers, because you actually have to look relative to the rest of the cube. This is actually F swap. These two are switching, and these two are switching, right? So this is actually F. If you do D2, you actually, like, the last QT works. This is L. So here you can insert an M2, D2. So the final solution is R, B2. We need to widen this, R wide, F2, R wide prime, U2, widen this, L wide, D2. And here we need to write this as Ly, but also insert an M2. So this basically becomes L wide prime, L2, D2. So let me just scrum it again just to show you that it works. Okay. So R, B2, R wide prime, F2, R wide prime, U2, Ly, D2, L wide prime, L2, D2. Works. And okay, it took me 8 minutes to do the entire explanation, but a lot of that was rambling. Like, that was really fast, actually. Especially considering then that on this kind of on this kind of slice, there are 10 plus zeros possible. So 10 ways to slice it so that it becomes +0. Obviously, some of them are like they're not doing anything because, like, for example, this one, like widening this and this actually doesn't do anything due to Sebastiano's slice theory. So instead of checking 10 things, you only need to check 6. Although you have to check 6 a little bit more thoroughly than you check the 10. But I think it's still worth it.